When the James Webb Space Telescope began observing the distant universe, scientists were not expecting to find a physical wall at the edge of reality. There is no known boundary where space suddenly ends. Instead, Webb was designed to push our ability to see farther back in cosmic history. Because light travels at a finite speed, distant galaxies are also time machines. When astronomers observe an object billions of light years away, they are seeing that object as it existed billions of years ago. This makes the James Webb Space Telescope especially powerful. Its large segmented mirror and infrared instruments allow it to detect extremely faint light from some of the earliest galaxies formed after the Big Bang. As the universe expanded, the light from these ancient objects was stretched toward longer wavelengths, making infrared observations essential. Soon after Webb began its scientific observations, astronomers discovered unexpectedly bright and surprisingly mature-looking galaxies in the early universe. These discoveries created an important scientific puzzle. The early universe was much younger than it is today. Only a few 100 million years had passed since the Big Bang and the most distant observations. Yet some galaxies appeared to contain large populations of stars and substantial amounts of material. How could such structures develop so quickly? The answer is still being investigated. Early headlines sometimes suggested that Webb had completely overturned modern cosmology. But science is more complicated than a headline. Some of the earliest galaxy candidates turned out to have their apparent brightness influenced by actively feeding supermassive black holes. In other cases, improved observations changed estimates of their masses or distances. This illustrates an important lesson. Discovering an unexpectedly bright object is not the same as proving that our understanding of the universe is wrong. However, Webb has still revealed something remarkable. The first galaxies were capable of forming stars surprisingly efficiently. Scientists now have evidence that the young universe was not simply a dark, empty environment waiting billions of years for galaxies to appear. Stars and galaxies began forming relatively quickly after the universe became cool enough for matter to assemble into increasingly complex structures. One of the most important questions involves the first generations of stars. The earliest stars were probably very different from stars like our Sun. They formed from material consisting primarily of hydrogen and helium, because heavier elements had not yet been produced in large quantities. These early stars could have been extremely massive. Massive stars live short lives because they consume their nuclear fuel rapidly. When they die, they can release newly created elements into surrounding space, enriching the gas from which later generations of stars and planets form. This process creates a cosmic chain reaction. The first stars transform simple primordial material into heavier elements. Those elements become part of later stars, planets, and eventually the chemistry associated with life. Webb is helping astronomers investigate how quickly that transformation occurred. Its observations of distant galaxies provide clues about their ages, chemical composition, star formation rates, and environments. Another major mystery concerns the period known as cosmic reionization. After the early universe cooled, much of space contained neutral hydrogen that absorbed ultraviolet light. As the first stars and galaxies became active, their energetic radiation gradually transformed this gas. Over time, enormous regions of the universe became transparent to ultraviolet light. Webb is helping scientists identify the galaxies that contributed to this transformation. The telescope is therefore doing more than finding distant points of light. It is reconstructing a chapter of cosmic history that occurred billions of years before Earth existed. Every ancient galaxy provides another piece of evidence about how quickly matter organized itself after the Big Bang. And the more Webb observes, the more scientists are discovering that the early universe was active, dynamic, and capable of producing surprisingly complex structures much sooner than many earlier observations suggested. But there is an even deeper question. If galaxies were already forming stars so efficiently during the universe's first few 100 million years, what physical conditions allowed them to develop so rapidly? Answering that question could change how we understand the beginning of cosmic structure itself. The discoveries made by the James Webb Space Telescope have forced astronomers to take a closer look at one of the most important periods in cosmic history, the first few 100 million years after the Big Bang. At that time, the universe looked nothing like the cosmos we see today. There were no mature galaxies like the Milky Way. There were no planets like Earth. The elements necessary for rocky worlds were extremely limited. Yet gravity was already working. Matter began gathering into dense regions dominated by dark matter. Gas fell into these structures, cooled, and eventually became dense enough for stars to form. The first stars transformed their surroundings. They produced ultraviolet radiation and created heavier elements through nuclear fusion. When massive early stars died, they distributed those elements into surrounding gas. This process gradually changed the chemical composition of the universe. Webb is now giving astronomers the ability to observe some of these ancient environments directly. One of the most surprising findings is that certain early galaxies appear to have formed stars at extremely high rates. This does not necessarily mean the laws of physics were different. Instead, the conditions in the young universe may have been very different from those found in today's galaxies. Gas was abundant. Galaxies were smaller and more compact. Interactions between young galaxies may have triggered bursts of star formation. In addition, the first generations of stars may have been significantly more massive than many stars forming today. These conditions could have allowed galaxies to grow rapidly. Another major clue comes from the chemistry of distant galaxies. Heavy elements such as carbon, oxygen, and nitrogen require stellar processing. Their presence tells astronomers that previous generations of stars must have already lived and died. Therefore, when Webb finds chemically enriched material in a very young galaxy, scientists can estimate how quickly earlier generations of stars must have formed. This creates a kind of cosmic archaeological record. Astronomers are not simply looking at galaxies. They are examining the remains of an ancient sequence of events. First came primordial gas. Then came the earliest stars. Those stars produced heavier elements. Later generations of stars formed from the enriched material. Eventually, galaxies became increasingly complex. Webb allows scientists to observe different stages of this process across enormous distances. The telescope is also revealing that some early galaxies were much more diverse than previously expected. Some appear compact and intensely active, while others show signs of more organized structures. These observations are helping researchers improve computer simulations of galaxy formation. However, scientists remain cautious. Astronomy is filled with uncertainties, particularly when studying objects near the limits of detection. Distance estimates, dust, black hole activity, gravitational lensing, and the physical assumptions used to calculate stellar masses can all influence what a distant galaxy appears to be. That is why follow-up observations are so important. A single surprising galaxy can raise a question, but a large population of similar galaxies can reveal a genuine trend. Webb's greatest contribution may therefore come from the enormous collection of ancient galaxies it is gradually assembling. As the sample grows, researchers can determine whether the early universe truly produced galaxies faster than expected or whether earlier models simply lacked sufficient information about the conditions of cosmic dawn. Either way, our picture of the universe is becoming more detailed. The so-called edge of the observable universe is not a physical boundary. It is a limit created by the age of the universe, the finite speed of light, cosmic expansion, and the sensitivity of our instruments. Webb has expanded that observational horizon. It has not looked outside reality. It has looked deeper into the past. And what it sees is astonishing. A young universe that was already beginning to organize itself into stars, galaxies, and enormous cosmic structures. The universe did not remain simple for long. Within a relatively short period after the Big Bang, gravity began building the foundations of the cosmos we see today. James Webb is allowing humanity to witness those foundations. Every distant galaxy is another page in the history of the universe. And as Webb continues observing, those pages may eventually reveal exactly how the first cosmic structures emerged from an almost unimaginably young universe.